Hello, everyone, and thank you for joining this Conf42 conference. I'm Jyoti Shah, IEEE Senior Member and Director of Applications Development at ADP. Today, we will explore how Agentic AI, autonomous, goal driven software agents can coordinate the continuous co evolution of microservices and micro-frontends in cloud native architectures. Microservices give us scalability, resilience, and independent deployments. Micro-frontends extended those principles to the UI layer. But the real challenge is synchronization. How do we keep dozens of independent teams and components moving at different speeds without breaking the user experience? In this session, I will walk you through the problem, the architecture of an agentic control plane, a real world case study, and future directions that move software from automation to autonomy. Let's start with the foundation, the mocked in architecture landscape. Microservices decompose applications into independently deployable services. Each owns a business capability, for example, payment, catalog, or user profile, and can scale or deploy independently. This improves resilience and team autonomy. Now extend that same principle to the UI layers. That's where micro-frontends come in. Teams can deploy front-end modules in React.js, Angular, and plug them into a shared container. This gives incredible speed and parallel deployment. But as you will see, it also creates an integration nightmare. Each team has its own framework, release cycle, and dependencies. So when one part of the system changes, others must catch up instantly. And that's where things start to break. As systems grow, we enter what I call the coordination crisis. API evolve, new endpoints, renamed fields, different responsive structures, framework heterogeneity. Teams use React, Angular, Vue independently. Manual bottlenecks. QA cycles multiply, rollbacks become routine. In large enterprise, you might have 25 microservices and 10 micro frontends spread across multiple teams. Each change must be communicated, tested, and synchronized. That coordination effort grows exponentially with every new component. The result? Frequent integration breaks, inconsistent UX, and deployment slowdowns, even though we moved to microservices to go faster. Let's zoom in on what I call the moving target problem. Every time a backend service evolves by adding a new endpoint, modifying a payload, or changing latency profiles, the dependent micro frontends must adapt almost immediately. If they don't, users see runtime mismatches, broken interactions, or sluggish experiences. So while our architecture is decentralized by design, its dependencies remain tightly coupled in practice. This is the core paradox of modern microservice ecosystems. We have gained team autonomy, but we have also inherited a constant chase to stay in sync. Enterprises running 25 plus microservices and 10 plus micro frontends face a mathematical explosion of version combinations. That's why traditional coordination models, ticket, manual testing can't keep up. We need systems that can sense and respond autonomously to this constant movement. So, how do we bring order to this moving target? The answer is Agentic AI. These are autonomous software agents with three core capabilities: perception, reasoning, and action. They perceive the state of the system, monitoring backend APIs, front end metrics, and telemetry. They reason, detect schema drift or behavioral anomalies, and plan adaptations. They act, apply validated changes with rollback mechanism if anything violates policy. Essentially, we are teaching a software to self-diagnose and self-heal, just as autonomous vehicles perceive and navigate their environment. Our agentic AI agents navigate code and configuration changes to keep systems aligned. The Agentic Control Plane, or ACP, is the framework that orchestrates these agents. It has four planes. The first one, observation plane, collects telemetry through open telemetry, API gateway logs, real user monitoring data. This is how the system sees itself. The second one, cognition plane, hosts the AI brains, reinforcement learning agents, optimize scaling and configuration. LLM agents generate code or config patches. Contract agents monitor schema capability. The third one, execution plane, applies changes using GitOps, pipelines, and service mesh controllers. Supports canary and blue-green releases with automatic rollback. The fourth plane, policy and governance layer, defines safety envelopes, approval thresholds, and auditable logs. These four planes work together in a loop of perception, reasoning, and action, continuously optimizing the system in real time. Let's see how these comes together in practice. So the first one is drift detection. The observation plane notices a schema change. Perhaps an API field has been renamed. The second one, impact analysis. The cognition plane identifies which UI components consume that field. The third one, solution generation. The LLM agents suggest a minimal code diff or adapter to restore capability. The fourth one, safe deployment. The execution plane deploys it to canary environment. The fifth one, validation and rollout. If service level objectives remain stable, the change is promoted. If not, it auto rolls back. What's important is no human has to manually coordinate these steps. They happen under governed automation. Here's a real enterprise example to quantify the impact. A global e commerce organization with 25 microservices and 10 micro-frontends adopted the agentic control plane. Before ACP, API changes regularly broke frontends and caused deployment delays. After deployment, adaptation latency improved by 35%. Front-end errors dropped by 40%. SLO compliance rose to 25%. Manual coordination reduced to 50%. In other words, they moved from reactive fixing to proactive, autonomous alignment with traceable audit logs for every action. Let's balance the discussion with both benefit and challenges. The strategic benefits: continuous synchronization between backend and frontend, reduced downtime through auto rollback, explainable autonomy, decisions are logged and auditable, enterprise scalability across frameworks and teams. What are the challenges? Training overhead for reinforcement learning needs quality telemetry, trust building for LLM generated code. It requires a sandbox validation, complex governance. We must define policies that balance freedom and safety. This is where the human element remains essential. AI augments team and not replaces them. Looking ahead, this convergence of microservices, micro-frontends, and agentic AI is just the beginning. Three areas stand out: explainable reinforcement learning, ensuring that the reason behind every agent action is transparent; knowledge graphs, mapping dependencies across services and UIs to predict drift before it occurs; federated learning, allowing different teams to share adaptation strategies without exposing sensitive data. Our goal is not just to automate, but to create systems that learn and govern themselves responsibly. To wrap up, the agentic control plane proves that autonomous coordination is not science fiction. It's already improving enterprise reliability today. By embedding AI agents that perceive reason and act under governance, we enable continuous co-evolution between microservices and micro-frontends. This is the next step in the DevOps journey, from automation to autonomy. Thank you for your attention and for being part of the future of cloud native engineering.